Hello friends, in this video we're going to look at this 5601A Cesium Beam Frequency Standard. This dates from somewhere in the 1970s or maybe early 80s. This can also be classified as an atomic clock. It contains a cesium beam tube here. That's the atomic clock part of it. I haven't powered on this unit or popped the lid, but we'll do that in a little bit. But first, let's look at the back. Here's the back. It's a little hard to see what all's going on here, but you can see 1 PPS there. There's 10 megahertz somewhere, which is the kind of the primary input for most signal generators. Got a degaussing attachment, and here's the primary power connector. That brings me to the first problem I'm going to be solving in the next section, is how to attach to this. This is one of these mill type connectors with 3 pins, and it's not the type of common connector that we have nowadays on computers and monitors and such. One of the things that's notable about this, it has this sticker on it: Aerospace Guidance and Metrology Center, repair date 6 April 1983. So we can reasonably assume this was running as of 1983. My guess is that this was surplused out from that facility, and it ended up being bought by somebody at an auction. My brother bought it again at an auction the other day. So here we have it. I'll take the lid off for the very first time. It has a big warning on the back that says 4,000 volts, so I'm going to keep my hands out of it. But we can at least do kind of a basic visual inspection. So aside from some normal dirt and dust, looks like it's in pretty good shape. Here's the plate on the cesium tube. We'll talk about that more later, but my guess is that this tube is worn out. They're quite expensive, and that's probably why this entered the surplus market. Let's look at a couple of other things here real quick. We've got a LED numeric display of some kind, some different indicators. This is kind of a calibration and operating selection control panel that helps you kind of fine-tune the thing. Curious Mark has done a nice video on this exact same unit, so if you want to get more about the details of how it actually works, he's covered that nicely. I'm not going to do that here. I'm going to really talk more about this unit in particular. The first challenge that I face here is rigging up some sort of power cable. This can be powered by either AC or DC in either 110 or 220 volts. There's this 3-pin AC connector on the back, and I think I'll be able to rig up something that's good enough to just kind of turn it on, not really a permanent solution, which would involve buying a proper connector and so on. But I'll go put that together and show you the result. I did a continuity check of these pins against the chassis, and this one on the left is the chassis ground, so that means the other 2 must be AC power. I've considered some alternatives for powering this on, and out of my big box of cords I found this one, which more or less fits. It's got bigger holes than the pins, but I think for just kind of an initial turn-on purpose, it'll work. It seems to engage reasonably tight, so that kind of suggests that the pins are making contact. So we'll turn it around and turn it on next. I was getting ready to shoot this video and plugged everything in and was going to turn on the power switch, and then I heard it humming, saw a light. This is a current limiter that's in series. It's not glowing, which means we're doing well on current. I think this unit pulls about 80 watts maximum, so 46 watts about. That's pretty good. It's the sticker on the back says 120 volt amps, meaning watts, but we can probably consider in some sort of idle mode that 40 makes sense. There's nothing to be concerned about here. So I'm hearing a high-pitched whistle. I don't know if you can hear that in the video, but you know, maybe, I don't know, 7 kilohertz, something like that. We've got the battery light on. This unit includes a battery backup. I'm going to assume it's lead acid batteries. We can pretty much assume the ones that are in here are shot. But let's turn off this light. Oh, I see now some LEDs. So that's a lot of good signs. Right on the front, we've got these different outputs, so I can hook those up to my little El Cheapo oscilloscope. See if anything's going on here on the control panel. I don't know what. So the switch here is to molt. I saw in another video that this has a an open loop mode of some kind. So I may need to turn that on. There doesn't seem to be anything bad going on here. Guess I'll need to look up in the manual what these different settings are for. So far, so good. Let's go ahead and hook it up to the oscilloscope and see what comes out. Got the scope perched on top here. This is a 5 megahertz output. Plug that in for the first time and see what we get here. I'll do the auto mode on the scope. Hey, looky there. We've got some sort of output. So it's a little hard to see here, but we've got showing 5 megahertz. This isn't exactly a square wave, but maybe it's not supposed to be. Not sure. Let's go to 1 megahertz. The same settings. Nothing coming out that's apparent. So that one looks dead. This one is supposed to be 100 kilohertz. Looks kind of shady. So let's go back to the 5 megahertz, since that kind of gave us our best results so far. I kind of thought if one of these outputs worked, they all would, but looks like the 5 megahertz is by far the best. The others look like they have problems, and those could be individually driven. I'm not sure what the 302 stands for. I think this unit needs a long warm-up time, like I seem to remember it was like 20 minutes to warm up. It's got a crystal oscillator with an oven in it, so that's probably the warm-up time. We may or may not be activating the cesium tube at this point. I'm not sure, depending on the switch setting that I have. So this is supposed to be 1 pulse per second. That looks like noise. So my hope was that this was a more or less functioning unit, with the possible exception that the cesium tube had gone bad. Oh, looky there. It got square for a second. Let's see what our... This is kind of an unproven cable, so maybe that's my major problem. Okay, we'll switch cables and see what happens. Well, I consulted the manual, found out that this is a sort of a built-in real-time clock. It wasn't moving before, but I've made some other adjustments that are part of the startup procedure of this unit that show in the manual. So you can see that this appears to be running at a 1 second rate. I'm going to guess that the 1 PPS coming out of here is correct now. We'll measure that next. Well, I've been using this cheap Regal scope, model DS1054. It's actually quite good for the price, but it's not quite good as scopes go. I've done a lot of manual adjustments. The auto feature on this got terribly confused by the signal, which has a lot of noise on it. But you can see the pulses here, and the delta between them is 1 second. Get in a little closer there. So we do have our 1 PPS coming out, and that makes sense relative to this display that's ticking along nicely. So there's a lot of good things happening here. I'm still in the open loop mode, so I don't know if the cesium tube is in action yet. I'm feeling for heat here, and no obvious heat. This actually, despite its size, isn't a real high-powered unit. I think it only runs like in the 80-watt range or something normally. Right now I'm reading, can't see that, but right now I'm reading about 47 watts. It went up when I switched the mode to loop open. So let's go for broke and switch the mode to oper, which I assume means fully operational, and see what happens. Okay, our seconds are still ticking away. No sign of smoke or any sort of real major malfunction here yet. So I went to oper. Our seconds are still ticking along. Our power is about the same at 47 watts. So there's really no obvious change in this. Of course, maybe there wouldn't be. The alignment process on this is kind of complicated. On the video by Curious Mark, he goes into a lot of detail on that on the second part of his series. I'm not going to go through the process of trying to calibrate this. So now with the rest of it working and our clock ticking away, I've plugged back to the 1 megahertz, and that came to life. So apparently the restart procedure is needed to get these other outputs to go. Here's 100 kilohertz, and I guess that's fine. Yep, it's reading 100 kilohertz on the dot, just as if we go back to the 1 megahertz, that's reading 1 megahertz on the dot. Now, of course, the Regal has some sort of quartz oscillator of its own. No reason to believe that it's super accurate or anything. But anyway, it does show us that this is kind of nominally working. And that's really a lot of my goal for this purpose, is to be able to tell the buyer when we sell this that it kind of nominally works. And then it'll be up to them to do the calibration and whatever, or if they just want it to be a museum piece, that's okay too. So let's push this standby read button and see what happens. I'm going to guess that this freezes. Oh, yeah, guess wrong. Nothing happened that I could tell. So overall, this is a pretty big success so far. No smoke got out. It's nominally working in its basic functions. We're still in the battery charging sense. I think that's what this light means. Have to look that up. Anyway, it's a pretty happy unit. Let's push the logic reset. I'm going to guess that makes the clock start over at 0. You have to hold it for a second. Okay, making a lot of wrong guesses here today. But that's part of the fun of this channel, is we see what's going on and make our mistakes along the way. So I think we're going to wrap this one up. In terms of resale, these typically go for about $500 as is. And you could say this one is as is plus, as in it nominally works, but you know, it may very well not be the true atomic clock accuracy that we hope for in this type of unit, because the guess is that the cesium tube is worn out, which is really what drives the extreme atomic accuracy. So this would make a fine museum piece, collector's item, and it may also, if I had something better to measure it with, it may also be sort of a good general lab standard. You can imagine the oven control on this is very good. assuming it's all working correctly. So this may be the kind of thing that's sort of highly accurate in a kind of an ordinary electrical signal generator sense, but isn't, accurate at the atomic level. So in other words, we probably won't be able to prove Einstein's theory of general relativity with this one, although its forebears did exactly that. So that wraps it up. Thanks for watching, and bye-bye.